Good morning. I am Riji, Associate Professor, Department of ECE. Today we are going to see about 5G concept and challenge, 5G new radio and cloud technologies. 5G network architecture and core will have on completion of topic students can understand the basics of 5G new radio and cloud technologies. 5G new radio. One of the significant changes in 5G architecture is the radio spectrum. 5G introduces a new specification of 5G new radio. Some of the key changes to the radio function in 5G are spectrum. So the spectrum from low band below 1 gigahertz to mid band 1 gigahertz to 6 gigahertz and high band 24 to 300 gigahertz. This high band is called as millimeter wave, that is 30 gigahertz to 300 gigahertz. Latency should be less than 10 millisecond. Beamforming should support large number of MIMO antenna which would work in high interference environment through a technique called beamforming. Internetworking with 4G coexistence with LTE by bringing an overlay network 5G spectrum. In order to achieve high speed and scalability, 5G support wide band of spectrum from low frequency band 1 GHz to mid band 1 GHz to 6 GHz and 300 GHz. Lower frequency can travel enough and propagate through high frequency. Lower frequency offer better coverage. Higher frequency will travel short distance, however it offers higher bandwidth. So for higher speed, millimeter wave is very important for 5G to offer high speed. In addition, for deploying large tower, 5G will require service provider to deploy large number of small towers to meet the speed and latency requirement. 5G coverage by supporting both licensed and unlicensed spectrum. 5G NRU is called as unlicensed spectrum. 3GPP has categorized the use of 5G and 6G spectrum band. The use of unlicensed spectrum significantly reduced the cost of deploying 5G network. Lies two types of NRU implementation: license access access, standalone NRU. License access access. So in this LAA deployment, service provider aggregated the licensed spectrum with the unlicensed spectrum to provide wireless service to customers. The point of aggregation can be a small cell which support licensed and unlicensed frequency. Alternately, mobile device can establish dual connectivity. One of the macro cell operating in the licensed spectrum and the small cell will operate in the unlicensed spectrum. LAA in 5G is similar to LAA is implemented in 4G LTE. LAA helps service provider in boosting the capacitance of the network. In standalone NRU, standalone implementation is unique and is appeared by competing with existing Wi-Fi technology, that is 5 GHz frequency. 5G NRU standalone implementation will help to accelerate the deployment of 5G in private network such as enterprises and industries. 5G NRU standalone deployment can support IoT use cases in enterprise, industries and communities. 5G NR support dynamic spectrum sharing, a new standard introduced in 5G. For example, 4G user can use a spectrum of 10 millisecond and the same spectrum can be taken by 5G user for 1 millisecond. Dynamic allocation of spectrum improve utilization of spectrum across 4G and 5G services. So this may starve the users in 3G network. However, dynamically spectral sharing enables smoother migration from 4G to 5G. So initially it is expected that more users will be in 4G and very few users will be in 5G. So from this topic, students can understand what is the frequency of 5G NRI FR1 frequency range. What is the following key enabler of low latency in 5G? What does edge computing aim to address in 5G? Increased centralized control of devices, bringing data processing, larger screen. So from this topic, students can understand about the radio and cloud communication technologies.